All right. So the nice thing about the last section in this class is it's actually really, really, really easy. Um, it's just sequences. So the reason it's important is because when you get into calculus 1 and calculus 2, you're going to need to know how to use sequences to do the calculus on them. So it's a good introduction to them and looking how the equations and stuff are written. So honestly, these 12 topics go by pretty quick, and then there's 9 of them I'm going to do on Wednesday, and those the only difference is those are geometric, where these are going to be more arithmetic sequences tonight. So the first few topics we're going to look at is basically just finding terms in the sequence. So to find a term in a sequence, you're just going to plug that number into the problem. So it's in this equation, we're just going to plug in 1 to the equation, and we'll get the answer. So plug in 1 to that. The answer is 67. We plug in 2. So 2 minus 1 is 1, times 5 is 5, plus 67 is 72. The other thing, the way to look at it is instead of us sitting there going through and constantly doing the calculations, the key piece of information is that 67 is my starting number and the 5 is my difference. So basically, I'm just adding 5. So the next one's going to be 77 and then 82. So you can either do it by plugging the numbers in or just understanding what the equation is, which is going to help you later on when we actually have to write the equations for it. So that's your starting number. That's your difference. Or if you think about it in terms of slope-intercept form of an equation, that's your y-intercept and that's your slope. So these are arithmetic sequences because they're based on addition and subtraction. A geometric series, the difference is multiplication. So this one right here, this is a geometric series because the term is actually multiplied by each one. So in this case, my starting value is at 5, and then my difference, or the multiple that I'm doing, is 4. So my first number is 5, and then basically it'll be multiplying by 4 each time. So the next one's 20, then 80, and then 320. So notice the difference between this one and the last one. The last one I was adding every term, arithmetic. This one I'm multiplying every term, so it's a geometric. Or if we're thinking about COVID numbers, that's the hockey stick. It's an exponential growth. This one is another sequence. It's just a little more complicated when you're going through and doing it. If you want, you are more than welcome to use Desmos to do this stuff too. So you can use the Desmos scientific calculator. So again, when we're looking at it, you're just going to type the problem into Desmos. So we have 3 to the x minus or plus 2. Plus 2 over 3 to the x. And then you can just do x equals 1. And if you click the little button, it gives it to you as a fraction. So my first fraction is 5/3. And then just change the x to 2. And we get 11/9. 3, 29 over 27. And if you look, we actually, once you do a couple of them, you might be able to, you can look and figure out the pattern from it. The top's going up by, basically the top is the bottom squared, or the factor, or 3 to the power, and the top is just adding 2 to it. So the bottom is going to be, the next one's going to be 81 on the bottom and 83 on the top. So it's the multiples of 3 and then adding the 2 on the top. Any questions on the first 3? Those are pretty simple. The next sequence is known as a recursive sequence. So one of the most famous recursive sequences that most people know is the Fibonacci sequence. So it goes 1, 1, 2, 3, 5, 8. And what Fibonacci does is it's adding the previous two terms. So it's recursive because you actually have to know the previous two terms to be able to add it up. So this sequence right here is recursive, which means I'm using the previous term to find the next one. So this first one, a to the first power, a to the 1, or a1 is 1. And my next one, I'm going to take that number, multiply it by -6, and add 5. So 1 times -6 is -6, plus 5 is -1. So that's my next term. Now I'm taking the -1 and plugging it into this problem and figuring out it again. So it's -6 times -1 is 6, plus 5 is 11. And then we do it again. So 11 times -6 is -66, plus 5 is -61. So recursive sequence. So I had a1 is 1, a2 is -6, and then it's times a1 plus 5. So -6 times 1 plus 5, which is -1. A3 is -6 times a2 plus 5, which is -6 times -1 plus 5, which is 11. And then a4 is -6 times a4. Oh, sorry, a3. A3 plus 5. So I get -6 times 11 plus 5, which is -61. So that's a recursive sequence. So you kind of need to know the previous terms to be able to figure out the next one. Factorials. So factorials are a shortcut to writing multiplication. So 4 factorial is 4 times 3 times 2 times 1. So 8 factorial is 8 times 7 times 6 times 5 times 4. 3 times 2 times 1. So when we're doing a problem like this, you could just do it in the calculator and get the number, get the answer. But actually, the way I really want you guys to look at it, because you're going to use it in a lot of other things, is actually to look at canceling things out. So 4 factorial and 8 factorial. Then I have 2 factorial and 7 factorial. So the top, I have 4 times 3 times 2 factorial. Then I have 8 times 7 factorial. So what I'm able to do is those 2's cancel out and the 7's cancel out. Because if I look here, that right there, that is 7 factorial. So then my final answer for this problem is just what's left at the top, which is 4 times 3 times 8. So I get 12 times 8, which is 96. That's going to come into handy when you're looking at any kind of probability, permutations, combinations, being able to break them down because they use factorials for most of that stuff. So understanding what a factorial is and how to break it down is quite useful. Another way you could have just wrote it, you could have just wrote it all out, 4 times 3 times 2 times 1, 8 all the way down, and then crossed out the stuff that matched up too. Either way would have worked. All right, the next set of problems is looking at finding sequences, and then we're going to go into finding equations for our sequences. So as long as it says it's an arithmetic sequence, that key is right there. That means the difference between the numbers have to be the same. So from here to here, I'm adding 4. From here to here, I'm adding 4. So the next term, I'm adding 4. So the next one would be 7. And then I'm adding 4 again. So the next one's going to be 11. So you're just looking for the pattern, and these patterns are going to be very simple. They're not going to be insanely complicated patterns. It's just arithmetic, so it's just adding or subtracting. Like if you're, instead of doing +4, I could have done -4. It's still the exact same concept as an arithmetic sequence. You're just adding a negative number instead. This topic's asking you if it's arithmetic or not, and then if it is arithmetic, what's the difference? So how much am I adding to each one? So you just look. So this first one, I'm going 2 to 4, so that's +2. 4 to 8 is +4. So I know that one is not arithmetic because it's not the same every single time. Because this first one goes +2, +4, +8. So that doesn't work. The next one, I'm minusing 4, minusing 4, minusing 4. So that is arithmetic. And the common difference is -4. The next one, I'm adding 6, adding 6, adding 6. So that is arithmetic. And my difference is 6. The first one would be an example of a geometric series because it's multiplication. It's multiplying by 2 each time. The next thing is asking for to find the 70th term in the sequence. So I'd like you to start now. They've given you the first 4. Find me the 70th. What do you think you need? Like 15, 20 minutes to add all those numbers up? No, there's an easier way to do this. The format of the equation is, if I always like to use the, so it's a to the n is basically like the slope equation. So it's the difference times n minus 1 plus the initial value, which in this case I'll call b. So it's like my y-intercept. So in this case, a to the n, my difference, so I'm going up by 7 in each one of these. So difference is 7, and it's n minus 1, and my starting value is 6. So if I wanted to find the 70th term, I can now just plug in 70 to the problem. So 70 minus 1 is 69. 69 times 7 is 483 plus 6. So my 70th term is going to be 489. So really what you're looking for when you're doing these equations, and we're going to be doing this for a lot of the rest of the problems, is that value right there. That's your difference. And horribly spelled difference. And that's your starting point. Once you have those two numbers, the rest of the formula is already there, and you can just plug any number you want into it. So if I wanted the 100th term, I can just plug in 100 to that. So we no longer have to look for the pattern and do out every single one of them. We have the formula to be able to do the calculations. Any question on the formula or the equation for the sequence? Because we're going to use that for the next like 3 problems. All right.
Can you go back for a hot second?
Sure.
Thanks a bunch.
No problem. All right, the next one says find the 16th term in an arithmetic sequence that has a common difference of 6 and whose first term is 5. So this one, they didn't give you the points, so we can't figure it out, but they gave us the information we need. So a to the n is 6 times n minus 1 plus 5, and they want the 16th term. So 16 minus 1 plus 5. So 15 times 6 plus 5 is 95. So once you have the equation, life becomes simple. And if you think about it, it's in essence no different than the slope-intercept form of an equation, the y equals mx plus b. The only thing is x in this case is n minus 1, because we're starting 1 point off. We're actually starting at 1 instead of at 0 on the x-axis. And it's not a line because the values of n are all integer values. So you're not going to have a half a point or anything else like that. So. All right, so the next one says, for a given arithmetic sequence, we have a 79th term is equal to 505, and the 5th term is equal to 61. They want you to find the 37th term. Remember I told you about distance is basically just like slope? So if we look at it this way, I have 2 points. I have my 79th point, so 79 is 505, and 5 is 61. So I can write those as slope and actually do my equation. So it's 505 minus 61 over 79 minus 5. So 505 minus 61. So I have 444 over 74. So this equals 6. So I have a to the n equals 6 times n minus 1, but I don't know the next value. So, but we can figure that part out. So if I know my 5th term is 61, and I know it's going up by 6 every time, so I'm going back. So if my 5th term is 61, so I have 61 equals 6 times 5 minus 1 plus b. So I can do 6 times 4 and then minus the 61. So that means b is 37. So now I can do, so a to the n equals 6, n minus 1 plus 37. And now I can find my 37th term. So it equals 253. So in essence, you're doing very similar to what we do for the slope-intercept form. We're finding the slope, then we plug one of the points back in to find the intercept part. All right, one more. Well, 2 more questions. One more and then. So this one's asking for just the equation. So we're going to do the exact same thing again. So a to the n, the difference is I'm adding 7 in this case, so it's 7, n minus 1 plus the initial value. So the nice thing is this one's one of the end topics that you have to do, but if you're using the equation along to find the rest of them, this topic is simple because you actually don't have to do much extra work. And you can write it with the parentheses, even though the example tells you not to, it will take the problem with the parentheses in it. So don't sit there and go back out and multiply it out to get the actual term with just n. Do make sure to use n and not x though. Otherwise, it'll just tell you to use the correct variable if you put in x. The downside is on like the knowledge checks and DSAs and, or tests and stuff, it will end up marking it wrong if you use the x. All right. Any questions on that with the equations and whatnot? Because the last topic's slightly different. Before I go into the last one. Okay. So the last topic is an infinite being able to compute sums. So basically, if I'm adding up a whole bunch of values, how do I find the sum of that value? So the formula for this one, so the sum of the numbers is n, and it's a to the n plus a1 over, okay, hold on a second. I think it's n plus 1. I can't remember the formula off the top of my head. 2. So the key when we're doing this one is we just need to find that information. So in the first problem, they give me the first term, they give me the last term, but they don't have me how many of them I have. So I need to figure out n. And the second one, they give me how many I have, but they don't give me the first term and the last term. So you have to calculate those and figure those out. So in this first one, a1 is -1, an is -421. So we can figure out how many terms there are by looking at the difference. So in this case, I'm subtracting 3 each time. So if we look at my equation, so an equals, my difference is -3, and it's n minus 1, and my first term is -1. So let's just we pick the last term. So -421 equals -3 times n minus 1 minus 1. So I have -420 divided by -3. So I get 140. So I get 141 is n. And you can do a quick little check just to make sure that works. So if I do the 140 times -3, and then minus the original one, and I get the -421, so it does work. So n is 141. So I have 141 times -421 minus 1 over 2. And I just type that all right into the calculator. And we get -29,751. So if I was to add all those numbers up from -1 to -421, I get to -29,751. The one with the summation, we're going to do the exact same thing. The difference is we're going to use the other equation for it, or the other information. So it's Sn equals n times a to the n minus a1 over 2. So in this case, I know my n is 94, and that comes from up top there. So I have the n right there. Now I need to know my first term and my last term. So my first term is I plug in 1 to the k, So 5 times 1 is 5. The last term, I have to plug in 94 to it. So 5 times 94 is 470. So I get S to 94. So the sum of the first 94 is 94 times 470 plus 5 divided by 2. And I get 22,325 as my final answer.
Professor, could you explain what that symbol is? How do we read that?
It's the summation. It's actually epsilon. It's the Greek letter epsilon, but it stands for the summation. So it basically means if you write out the sequence, you're going to add up every single number that goes out. So you're going to add up 5 plus 10 plus 15 plus 20 and keep going up all the way up until, in this case, the 94th number, the 94th term. Does that answer your question?
Could you explain it one more time?
So it's the Greek letter, it's the capital letter for the Greek letter epsilon. We use it in math for summation. So basically, you know how the first one has got the -1 plus -4 plus -5 plus -421 all the way up, and those little dots keep going all the way to 421?
Right.
The summation symbol is just an easy way to collapse that down. So it's saying I'm going to add up all the terms, and it's 5 times k in this case, and I'm going to add every one of those terms. So I'm adding 5 plus 10 plus 15 plus 20 plus 25, keep going all the way up to 470. It just allows me to write it in a simpler form, in an equation or a format that allows me to show all those values.
So 470 though, where did you, sorry, where did you?
That's the 94th term. So basically all I did is I plugged in 94 to the original problem.
Oh, got it. Okay, got it.
So out of all the topics, this is the only one I knew he was going to have trouble with in this section. So I have no problem going through and explaining it a little more. And you don't have to put the commas, they just like the commas. So, but that's it. I'm going to actually end this.